Hi, in this video, we are going to discuss the absolute and relative motion. Before we continue, you need to master the background of the vector algebra. Let's start with the dot product. So A dot B is equal to the magnitude of A multiplied with magnitude of B cos angle. The symbol theta is the angle between the vector A and vector B and is measured between 0 to pi. For example, you have vector A from the origin to A here, and you have vector B from origin to B here, and when you take the A dot with B, then the angle between them can be measured here. Given vector A is equal to this and vector B is equal to this, take the vector A dot product with vector B. You will get the same result by taking vector B dot with vector A. So first of all, you look at the x direction, which is 1 and negative 1 here. Take the multiplication between them and take the summation for the multiplication in y direction, 2 multiplied 2. Lastly, take the summation for 5 multiplied with negative 4. This gives you negative 17. We continue to find the magnitude for the A vector and magnitude for the B vector here. They can be found by using this formula. Take the square root of the magnitude in x squared plus magnitude in y squared plus magnitude in z squared. Then you obtain this answer. Repeat the same procedure to obtain the magnitude for vector B. By substitute the dot product result inside this formula and the magnitude result here, after you rearrange it, you should obtain this. Then you can find the angle to be the arc cos for negative 0.677, which gives you 132.63 degrees. So this angle is the angle between the vector A and vector B. So in general, if you have two vectors A and B, you can perform A dot B vector by using this operation. And then you can continue to use this equation to obtain the angle between them. If the angle between two vectors is 0, so in this case, your vector B and vector A are in the same line. Therefore, their angle is 0. If the angle is 0, cos 0 will give you 1. So in this case, your cos 0 will be equal to 1 here. Therefore, the dot product between vector A and B is equal to magnitude of vector A multiplied with the magnitude of vector B. For example, if you take the vector I dot with I, you obtain 1. Same to the vector j dot with j, k dot with k. This is because these two vectors are in the same direction, therefore the angle between these two vectors is 0. When you take cos 0, you obtain 1. So we know the magnitude for I vector is 1, therefore you obtain 1 in your right hand side. So the dot product for these two vectors is equal to 1. On the other hand, if your angle is equal to 90 degrees, so in this case, your vector A and vector B is 90 degree different. And we know cos 90 is equal to 0. So if you substitute this inside 0, you obtain right hand side equal to 0. Therefore, when you take the dot product between vector A and vector B, if both of them are 90 degree different, then you will obtain 0. For example, if you take I dot j or j dot k or k dot I, you obtain 0. This is because I, j, k are 90 degree different to each other. Therefore, when you take cos 90, you obtain 0 on the right side. The formula for the cross product is given here, where you have vector A crossed with vector B is equal to magnitude of vector A multiplied with magnitude of vector B multiplied with sine angle. So this is the magnitude. And then after you perform the cross product, you should obtain a new vector, where the AB sine angle here is the magnitude of this vector, and vector here means the normal direction. In simple, if you have a vector A and vector B that is separated by angle, then when you take A cross with B, the result of A cross B will be in the normal direction, which is over here. So you see the result of the A cross B is 90 degrees away from the A vector and 90 degrees away from the B vector. Previously we have vector AB to be this, and the angle between them is found by 132.63 degrees. If you want to know the normal direction to these two vectors, then you can perform the cross product. Cross product can be found by using this determinant formula. Take the vector A 1, 2, 5 cross with vector B negative 1, 2 and negative 4. First of all, take the I vector here and then take the determinant for this number. Continue with the second element J, and then you need to cross the corresponding row and column and take the determinant for the remaining number. So you have 1, negative 1, 5 and negative 4. Repeat the same procedure for the last element K here. Cross the corresponding row and column, then take the determinant for the remaining number. So you have 1, 2, negative 1 and 2. Lastly, put the sign to be plus, negative and plus. Then we continue to solve the determinant here. 2 multiply negative 4, you obtain negative 8. Minus with 5 multiply 2, you obtain 10. So solve this determinant, 1 multiply negative 4, you obtain negative 4. Minus with 5 multiply negative 1, you obtain negative 5. Lastly, 1 multiply 2 minus with negative 1 multiply 2, you obtain negative 2. Then we can perform the calculation, you obtain negative 18i. So here negative negative become positive, 5 minus 4, you obtain 1. So you obtain negative j here. Lastly, 2 plus 2, you obtain 4k. So when you take vector A cross with vector B, so you obtain the result negative 18, negative 1 and 4. So this vector is 90 degrees away from vector A and vector B. If you don't believe the angle between them is 90 degrees and you want to check them, you can use the dot product. So take the vector A dot product with your vector A cross B is to be equal to magnitude A multiply magnitude of B cos angle. So take the vector A 1, 2, 5 dot with the cross product, which is negative 18, negative 1 and 4. 1 multiply negative 18, you obtain negative 18. Continue. 2 multiply negative 1, you obtain negative 2. 5 multiply 4, you obtain 20. So 20 minus 18 minus 2, you obtain 0. So this is the result on your left hand side. So 0 equal to cos angle. where the magnitude, okay, take the 0 divided by this magnitude, you still obtain 0. So angle at 90 degrees will make cos 90 equal to 0. With that, we success to prove that the angle between vector A and the vector A cross B is 90 degrees. You can repeat the same procedure and check the angle between A cross B and B. You will obtain the same result, which is 90 degrees. So you must master the operation to perform the cross product by using this procedure to obtain this answer. If you find the magnitude for A cross B by taking the square root of 18 square, 1 square, and 4 square, and you should obtain the magnitude equal to 18.47. And then you can express the vector A cross B to be this, where you have the magnitude 18.47 multiplied with the unit vector. The unit vector has magnitude equal to 1, therefore you need to take the original vector divided by the magnitude here. Basically, this unit vector is the normal vector here, n. And the magnitude of 18.47 is equal to AB sine angle here. So to find the magnitude A, just take the square root of 1 square plus 2 square plus 5 square, then you should obtain this. Then you can find the magnitude B to be square root of negative 1 square plus 2 square plus negative 4 square. Then you should obtain this answer. Sine angle, where the angle is 132.63. So if you multiply these three numbers together, you should obtain 18.47, which is the magnitude for the A cross B. So previously, when we take A vector cross with the B vector, you obtain the answer to be this. How if you take the B vector cross with A vector? What will be the answer? So to know the answer, you can find using the normal operation IJK. Substitute the B vector inside, which is negative 1, 2, and negative 4. And substitute the vector A inside, negative 1, 2, and 5. Then you can get the answer. You need to be careful that B cross A is not equal to A cross B. And you must know B cross A is equal to negative A cross B. So previously you obtained A cross B to be this direction, and you can find it by using the right hand rule. So let's say this is your A direction and this is your B direction. So when you take A cross with B, then you can use the right hand rule to obtain the final result for A cross B. In this direction, follow your thumb when you cross your finger from the I direction to the J direction. So previously, when you take the A cross with B, you can use the right hand rule by crossing the finger from the A direction to the B direction here. Then the thumbnail will point to the final product, which is in this direction. So this is the direction for A cross B. And previously we success to find the A cross B to be this answer. On the other hand, when you take vector B cross with vector A, then you need to point your finger to the B direction first and cross it towards the A direction. And the direction of your thumbnail will be in here. So you see this direction is opposite with the A cross B. Therefore, B cross A is at the opposite direction to the A cross B. With that, we success to obtain your B cross A is equal to negative to this item. So you obtain 18, 1, and negative 4. So it's very important for you to understand why A cross B is not equal to B cross A. So you can find it by using the right hand rule here. Besides that, you know the I direction is 1, 0, 0. Your J direction is 0, 1, 0. When you take I cross with J, you can perform this operation. Take the determinant for ijk. So this is your I100, this is your J010. So I remain here, J here, you have negative J, K here remain, and then cross the row and column for the I, you obtain 0100, which is this. Cross the element, okay, in J direction, so you obtain 10 and 00. This. Lastly, cross the column and row for K element, then you obtain 1001. 1001, which is this. So perform the calculation for this item. So this item, when you multiply, you obtain 0. This item, 0 plus 0 is still 0. Lastly, for this item, you obtain 1. So this is the result for the I cross J is equal to K vector. With that, we success to obtain I cross J equal to K vector. So if you reverse it by taking J cross with I, so it will be opposite to the K direction. Therefore, J cross I is equal to negative K. So if you combine these two, you found that I cross J is in the opposite direction to J cross I. So this is your ijk direction. If you apply I cross with J, you obtain K direction. If you take J cross with I, then you obtain negative K direction. You can also apply this to other axes. For example, take the J cross with your K. By using the rank rule, you obtain I. If you take the K cross with the J here, then you obtain negative I. Lastly, if you take K cross with the I direction here, then you obtain J. If you take I cross with the K direction, then you obtain negative J. Now you should have better idea when you take I cross with J, you obtain the K. J cross with the K, you obtain I. And K cross with I, you obtain J. If you reverse it, J cross with I, you obtain negative K. K cross with J, which is here, you obtain negative I. And lastly, I cross with K, which is here, you obtain negative J. If you perform cross product between two vectors that are in the same direction, for example, I and I here, they are in the same direction, therefore the angle is 0. So if you substitute 0 inside here, you obtain sine 0 equal to 0. Therefore, the cross product between I and I, which is in the same direction, will obtain 0. Therefore, you obtain J cross J, K cross A, B cross B, or A cross 5A will be equal to 0. This is because all of them are in the same direction. If you have two vectors A and B and take the vector A cross with B, we can use the determinant method and you should be able to obtain this answer. This is the proof for the A cross B product. So you have two vectors here. So you need to multiply the A1i to each element here. Then you obtain the first row. Multiply the second element to this vector, you obtain the second row. Multiply the third element to this vector, then you obtain the third row. So you know I cross I, J cross J, K cross K will be equal to 0 because they are in the same direction. I cross J, you obtain K. J cross I, you obtain negative K. Therefore, you obtain this element. K cross I, you obtain J. I cross K, you obtain negative J. Therefore, you obtain this element. J cross K, you obtain I. K cross J, you obtain negative I. Therefore, you obtain this element. With that, we prove that we can use the determinant to find the cross product between A and B vector. So if you perform B cross C first, and then take the A dot with B cross C, then this is called the scalar triple product. For example, if you have vector 1, 2, 3 dot with, in bracket, let's say you have 0, 1, 0 cross with 2, 1, 0. You can perform the cross product first by using this equation, and then only you perform the dot product. Or you can do it in one step by taking the determinant for vector A, B, and C. For example, we have vector A to be 1, 2, 3, vector B to be 0, 1, 0, vector C to be 2, 1, 0. This is equal to 1, negative 2, plus 3. So 1 here, when you cross it, you obtain the determinant for 1, 0, 1, 0. Then you cross the column for the second element here, then you obtain the determinant to be 0, 2, 0, 0. Lastly, cross the column and row here, you obtain 0, 1, 2, 1. And this one you obtain 0, 0 minus 0 you obtain 0. Lastly, 0 minus with 2, so you have negative 2. So the final answer here is negative 6. Previously you learned how to perform the scalar triple product A dot B cross C here, where we use the determinant. For the first row you have the A vector, second row you have B vector, and C to be the third row. And you obtain the answer to be negative 6. So we see A dot with the B and cross with C. So by using the cyclic property, you also can perform B dot with C and cross with A, which is this. And you can write the determinant to be B first, 0, 1, 0, and then continue with C, 2, 1, 0. Lastly, continue with A, 1, 2, 3, and you still obtain the same answer. By using the cyclic property, you also can take the C dot with A and cross with B, which is this. Then you can write the determinant to be C first, which is 2, 1, 0, followed by A, 1, 2, 3, followed by B, which is 0, 1, 0. And if you solve this, you should obtain negative 6. So you have learned how to perform the scalar triple product, and the result is in a scalar, which is a number. On the other hand, if you take the A vector cross with B cross C, then the result will be in vector. So this is called the vector triple product. You should know how to perform the B cross C by using the determinant, and you should get this answer. If you perform A cross B cross C, it means you need to take the vector A, cross again with the B cross C answer. So with that, you obtain a new vector that is perpendicular to A vector and perpendicular to the B cross C vector. Besides perform the vector triple product using this approach, you can also simplify it by using this equation. You have A cross B cross C equal to the B multiplied with A dot C minus with C multiplied with A dot B. So this is called the BAC CAB identity. For example, let's say your B vector to be 1, 0, 3. Your C vector here to be 2, 1, 0. Then after perform the cross product, then you should obtain this answer. So you substitute negative 3, 6, and 1 inside this equation, and then let the A vector to be negative 1, 1, and 0 here. Then you shall obtain this result for this vector triple product. Besides that, you also can use the BAC-CAB identity to compute the vector triple product here. So substitute B vector here, A dot C here, minus with C, A dot B, and then you perform the dot product. Negative 1 multiply 2, you obtain negative 2. 1 multiply 1, you obtain 1. 0 multiply 0, you obtain 0. This gives you negative 1. So negative 1 multiply this vector, you obtain negative 1, 0, and negative 3. Continue with this dot product. Negative 1 multiply 1, you obtain negative 1. 1 multiply 0, you obtain 0. 0 multiply 3, you obtain 0. Therefore, this product is negative 1. Negative 1 multiply with negative here, you obtain positive. Therefore, this part cancel. So take this, add it with this vector, and then you shall obtain the answer equal to this. You see, there are two ways to perform the scalar triple product. You can also use these two different approaches to compute the vector triple product. You can use any method to solve it, as both methods give you the same answer. In this example, you have a particle moving in a circular path with radius r. So this is the particle. At this particular moment, you see the tangential velocity where v equal to ds over dt. S is the displacement, which is equal to r multiplied with theta, and the velocity can be equal to the radius multiplied with the angular velocity. So this thing is rotated in a circular motion with angular velocity omega. Omega is equal to d theta divided by dt as well. So we know the direction for the velocity will be always tangent to the path. How about the direction for the omega? You see the tangential velocity has different direction with angular velocity, where at particular moment p here, so the velocity is in tangent to the path. In next moment, the particle moves to the position p prime here, and you see the direction for the velocity change. Therefore, the angular velocity will be in this direction. And by using the right hand rule, the angular velocity vector will be in perpendicular to the plane of rotation. This formula is very important in applied mechanics. Velocity vector is equal to angular velocity vector crossed with radius vector. If your angular velocity vector is given in this direction, radius vector is in this direction, then take the angular velocity vector cross with the radius vector, you obtain the direction for the velocity vector here. So by using the right hand rule, by taking the omega cross with the radius, you obtain the velocity direction to be here. Therefore, this formula is valid. You need to be careful, this velocity vector is not equal to r cross omega. This is because when you take r cross omega, you will obtain the velocity in the opposite direction. So this is wrong. So if you take r cross omega to find the velocity, you will obtain the direction for velocity over here. So it doesn't make sense because when the angular velocity rotates in this direction, however, your velocity in this direction. So don't use this formula to compute the velocity. You have to use this.